In this video, we're going to learn about an algorithm called odd-even sort, or parity sort, or simply brick sort. The algorithm is closely related to bubble sort and therefore also to exchange sort. In fact, the algorithm is almost identical to bubble sort, but with one important twist. Bubble sort compares the leftmost array element with the second leftmost element of the array. If the first of these two elements is larger than the second, the two elements are swapped, okay? And then, after it had now just compared the first and the second element, bubble sort compares the second element with the third element and so on. So what is it that brick sort does, and what is it, and how is that different? Let's start with the similarities though first. Brick sort also starts at the very left, and it also compares the leftmost element with the second leftmost element. However, in the next step, it does not compare the second element with the third element, which is what bubble sort did. Instead, brick sort now compares the third element with the fourth element. And after that, it compares the fifth with the sixth element and so on. So the key difference here is that bubble sort compares first with second, and then comes an overlap because bubble sort then compares second with third element and then third with fourth. So bubble sort has this overlapping going on, while brick sort compares first with second, third with fourth, fifth with sixth, and so on. So no overlap. Okay? And brick sort therefore compares all even indexed array elements with their right-hand side neighbors. But once it has traversed the entire array, brick sort, just like bubble sort for that matter, starts over from the very left. This time, however, brick sort compares all odd indexed array elements with their immediate right-hand side neighbors. So notice that depending on whether we're working with zero-based indexing or not, we could also say that brick sort first works with the odd indexed pairs and only then with the even indexed pairs. Okay? Anyway, it is this switching between odd and even indexed pairs that gives rise to this rather peculiar pattern in the center of the array, which looks like a constant up and down of short and tall bars. So to the very left, we have this roughly sorted area of the array. To the right, we have the actually sorted area, but in between, we have this up and down of tall and short bars. Let's have a look at how brick sort works in detail. We'll start with the exact same array that we had in the other videos. So we'll have 2, 5, 4, 1, 3 as our unsorted array. And what brick sort does, just like most other sorting algorithm, it starts out with comparing the first two elements, so 2 and 5, the first and the second element in the array. No swap is necessary, 5 is greater than 2, so no problem here. With exchange sort, let me just quickly go back here. We saw that the array then compared the first and the third element. Let's go to bubble sort. Let's just scroll up here. Bubble sort then compared the second and the third. So exchange sort, first and third, bubble sort, second and third, and brick sort has yet another way of doing things. It's comparing the third and fourth element. And brick sort then realizes, okay, 4 is greater than 1, so we'll have to make a swap, and the array then reads 2, 5, 1, 4, 3. So what brick sort just did here is it said, okay, I'm first going to have a look at this 2 and compare it with its immediate right-hand side neighbor. And then I'm going to do that with this 4. And the idea here is that brick sort, or as it's also called odd-even sort, it just goes through the even indexed array elements here. So 2, that's the 0 index position. So I'm just going to say 0 is an even number. I'm not really sure whether 0 is either even or odd, maybe both, maybe none. I don't really know. But if we have like 6 and 4 and 2 as even numbers, it kind of feels natural to treat 0 as like another even indexed array element, okay? Even array index. So we're always comparing these even indexed array elements with their immediate right-hand side neighbors. So it's 2 and 5 and 4 and 1. And once we're done with that, once we have gone through the entire array, we'll start over. But this time, we'll have a look at the odd indexed array elements. So we are not starting with the index location 0, but we are starting with 1. And in this case, this is then the second element. Remember, Python uses zero-based indexing. And now we are comparing this 5 with its neighbor, 1. We are seeing that they are out of order, so we swap them, and we have 2, 1, 5, 4, and 3. Now the array says, well, I'm just going to jump to I is equal to 3 now, which is the fourth element, 0, 1, 2, 0, 1, 2, 3, I'm sorry for that. First, second, third, and fourth element, okay? And yeah, so we're now comparing 4 and 3. Again, they are out of order, so we have to make a swap, and the array now reads 2, 1, 5, 3, and 4. Okay, then we are going back to having a look at the even indexes. So we're starting back over here. 2 and 1, we got to make a swap. 1, 2, 5, 3, and 4. Then we're looking at 5 and 3. And here we again have to make a swap. So we'll swap these, and now it's 3, 5, 4. The array now reads 1, 2, 3, 5, 4. Okay, so one final pass. We'll have a look at the odd indexes again. We are looking at the this 2 and this 3 here. They are in order. No swap is necessary here. So we'll just copy paste this array once more. 1 for 3, 5, 4. This is now almost sorted. Now we're comparing 5 and 4. Final swap to be made because this 5 is greater than that 4, obviously. And we have 1, 2, 3, 4, 5. As with the other algorithms, there are a couple of additional iterations involved until the algorithm will terminate. But I'm not going to go through them in this numerical example here because it's just copy pasting this array over and over again because it's already sorted. Anyway, let's code this. So as before, we'll now define a function. I'm in a new script called brick.py. So I'm going to mention this now before I'll start coding, finally, for once. So new script brick.py. And within this script, we'll now define a function called bricksort. I'm going to bricksort A. And as before, we'll define our local variable n as the length of the array. Similar to what we had with BOGO sort, we'll have a Boolean, which is sorted, and we'll assume that this is false. Now we'll start a while loop. While not is sorted. Okay, this has to include this underscore here. So while the array is not sorted, what are we doing? Well, first we're going to go through the even indexed array elements. So I'm just going to put even indexes down here. And then we're going to go through the odd indexes. Okay, so we'll type for I in range 0 to n minus 1. We don't have to put n here because we'll always be comparing with the right-hand side neighbor, so we don't have to have n here. N minus 1 is perfectly fine. But what's important, if we only want to have the even indexes, right now this would not work because it's doing 0, 1, 2, 3 until it reaches n minus 1. So we have to increase the step size. And this is the third, which is an optional argument within the range function. So if we specify another parameter or argument here, this will determine how large the steps are in between two elements that this range function is going through, okay? So here we'll now make a double step. So we'll start at 0, and then we're not going to go to 1, but to 2, and then to 4, 6, and so on. Okay, and just put a pass here for now, and copy paste this down here. Because when we're traversing through the odd indexes, we'll do something very similar. But we'll simply start at 1 and not 0, and then we'll have 1, 3, 5, and 7, and so on. Okay. Okay, so we are comparing the ith array element, this is this index here, with I plus 1. So or the element at position I plus 1. So if I is greater than the number that's coming after it, well, that's when we'll have to make the swap, right? So we're swapping AI plus 1. So now we'll have to put these in reverse order here, AI plus 1 and then AI. And this will be the swap. And whenever we made that swap, we'll want to reset this Boolean variable to, okay, what's happening here? Hey, go back. Okay, we're going to set this to false. Why false? Well, we just made a swap, so we know that the array was not sorted yet. And now we can just literally copy paste all of this down here. Okay? But there's one thing that we have to do. So once we traversed through all of this and we have not made a swap, And once we traverse through all of this down here and we haven't made a swap either, well, at what point is this while loop going to stop? So in between these two, we'll just assume that is sorted is true. So we'll just type is sorted equal true. Now every time that we're making a swap, we'll set that back to false, so no problem here. But once this passes without any swaps being made, we know that we have found the correct array, hopefully. We'll test this in a second. And once this is the case, we are breaking out of this while loop here and the algorithm will terminate. So let's see whether this works. I'm just going to copy paste what I have up here. Okay, copy paste this down here. And now we'll print this. Okay. And now we are going to brick sort it. Brick sort A, and then print it once more. And voila, it appears to be working. 2, 5, 4, 1, 3, 1, 2, 3, 4, 5 after we applied brick sort. Nice. Let's delete this. And now there's really just one thing left to do. We have to introduce yield statements. So we're going to yield every time that we made a swap. So we'll just say yield A. And I'm thinking about yielding the ith element. Here, you'll see how this plays out graphically. And I'm going to copy paste this down here. And you know what? When we're going through even indexes, let's use a different color than compared to what we're using when we're going through the odd indexes. And here I'm just going to say go through odd indexes. And here I'm just going to say go through even indexes and go through odd indexes. And so to change colors, we'll just paste this I here into the second highlight list. And this should really be it. So let's go back to the main. Go here and from brick, that's the new file, brick.py, which you can read up here. We'll now import brick sort. And now we can just copy paste this down here and run this. Okay, there we go. It appears that we're not floating the correct element. So we're floating the one after that, I think. So let's change this. I'm not sure. Okay. So let's have a look at this. Go here and see what happens if we change this to i+1. Because we are yielding after we made the swap, right? So we're yielding after we made the swap, and that's why we have to put i+1 here. So let's have a look at this. And there we go. The bubble is now floating. So this is looking nice. But it's not giving us this special pattern that we saw before. This is because in the other animation, I yielded also the in-between steps. So there is no right or wrong here. You might say we are artificially slowing down the animation here. If we are including more than just like the frames after the swaps. But I think it makes it easier to understand this algorithm if we are yielding before this and then we only need I. So I'm just going to copy paste this here. So now we're having a picture with every iteration through the array, not only when we were making swaps. So let's have a look at this. Okay, so I think this looks a lot better now. And now we can see this pattern here where we have tall bar, short bar, this kind of thing until the array starts to get sorted at the end here. And obviously, since we're floating all the large elements away from the left-hand side of the array, we'll also have this sorted section up here, then this cool thing in between where it's just going up and down, and then the sorted section, the actually sorted section over here, okay? Anyway, the array will now soon be sorted, and I think this is a great point to then stop this video. Thank you very much for watching. See you in the next one with COM sort or cocktail sort. Bye!